In this video, we're going to define the trigonometric functions using right-angle trigonometry. So that means we're going to use a right-angle triangle. So trigonometric functions provide a way to relate the angle of a triangle, or unangle of a triangle, to some of the side lengths of that triangle. Okay? Now it's always a ratio of two side lengths. So similar triangles have the same angles, but different side lengths, but that does not affect the trigonometric functions. Okay, so let's start by defining a right triangle. I'm sure you already know what this is, but a right triangle is a triangle in which one angle is a 90-degree or right angle. Okay, so if I draw a picture, okay, so this is a right triangle. So this angle here, this is the symbol they usually use, but that's a 90-degree angle. So when you have that, the side across from the 90-degree angle, this side is called the hypotenuse. Okay, and the other sides are called the legs of the triangle. So the sides that are next to the 90-degree angle are the legs, and the side across from it, so let's just do a little arrow. So across from the 90-degree angle, that's the hypotenuse. Okay, now so I'm going to draw another one over here, a little bit bigger maybe. Okay, so that's a triangle. So here's a right angle. So if I label the sides, let's label them A, B, and C. Okay, C is the hypotenuse. Okay, but if we want to consider this angle, let's call it theta. Okay, then we have other names for B and A and B. So they're the legs of this triangle, yes. But we also call A, this is in terms of theta. Okay, so A is the adjacent, the adjacent side because it's right next to theta. And the one across from theta, that's the opposite side. Okay, and this is what we use to define the trig functions. So the sine of theta, which we normally write sin theta or sine theta, this is the opposite over the hypotenuse. So it's equal to B over C. Okay, so it's the ratio of the opposite side divided by the hypotenuse side. The cosine is the adjacent over the hypotenuse. Okay, so that's going to be A over C. The tangent is the opposite over the adjacent. Okay, so that's B over A. Secant of theta, or sec theta, this is the hypotenuse over the adjacent. I can't spell. Over the adjacent. So that's going to be C over A. Cosecant of theta is the hypotenuse over the opposite. So that's C over B. Okay, and cotan is the adjacent over the opposite. So that's A over B. So that's how we define them with a right triangle. Now, all 6 of these trig functions can be, so maybe let's just number them, can be represented in terms of just sine and cos. Okay, so some of them more easily than others. So I'm going to start with secant theta, actually, instead of tan theta. Secant theta is the hypotenuse over the adjacent, but cosine of theta was adjacent over the hypotenuse. So it was just the flip. So secant is actually just 1 over cosine theta. Okay, similarly, cosecant is the flip of sine theta. So cosecant is just 1 over sine theta. Okay, now tan theta, if we look, so this is b over a. So that's actually b over c divided by a over c. So that's actually sine theta over cos theta. Okay, so if you divide the two values of sine theta and cos theta, you get b over a, which is tan theta. So tan theta is sine theta divided by cos theta. And then cotan is the opposite of that. So it's 1 over tan theta because it's the flip of tan. But that is actually the flip of tan, which is cos theta over sine theta. So in terms of sine and cos. So those are the 6 trig functions. Now you want to be careful about how you work with them. So they're functions. Okay, so theta is the input. It doesn't have to be theta. Maybe you call it x or beta or y, whatever you want your input to be called. But it's sine of theta. Okay, so you have like brackets around here. So for instance, okay, this happens all the time. So if I write sine theta over theta, I cannot cancel thetas. Okay, it looks like they're multiplying, but it's actually of. So, so you can't just say that's sine. Okay, that does not make sense. Okay, it's like having the empty square root. So I mentioned that before. So if you have f of something, it's a function evaluated at that thing. So you cannot cancel inside of that. Okay, it's the same for the trig functions. Okay, so you cannot cancel if it's inside the trig function. It's stuck inside. So let's do an example. So find the exact values of the 6 trig functions for angle theta here. Okay, so this is the angle we're talking about. So that means that the 8 is the opposite side because it's across from that angle. The 6 is next to that angle, so it's the adjacent side. And this side over here is the hypotenuse, okay, because it's across from the right angle. Now we need to determine the length of that side. So here's you want to use the Pythagorean theorem. Maybe I should just write this. Okay, so for a right triangle, I'm just going to draw it. Okay, so if I have a right triangle with A, B, and C, that means that C squared is equal to A squared plus B squared. So the sum of the squares of the legs is equal to the square of the hypotenuse. So that's a rule for right triangles. So that means here, the hypotenuse length is going to be the square root. So let's just write it here. So the square root of 8 squared plus 6 squared. So 8 squared is 64 plus 36. So this is square root of 100, which is actually 10. Okay, so that length is 10. Okay, so then we want to just write all our trig functions out. Okay, so we have sine theta, cos theta, tan theta. Okay, so sine theta is the opposite over the hypotenuse. So that's 8 over 10, which is the same as 4 over 5. Cos theta is the adjacent over the hypotenuse. So that's going to be 6 over 10, which is the same as 3 over 5. And tan theta is the opposite over the adjacent. So that's 8 over 6 or 4 over 3. Okay, and then 4, 5, 6. Now I'm going to line them up. So I'm going to do cosecant theta, and then secant theta, and then cotan theta. So I'm going to talk about why I did this order. So if you remember, cosecant theta is 1 over sine theta. So I lined it up with the sine theta, so it's just going to be the flip of that. So if you remember the definition, it's going to be the hypotenuse over the opposite, but you could just think it's the flip of the sine, so that's going to be 5 over 4. Okay, similarly, cos theta is 3 over 5, and secant theta is 1 over cos theta, so this one has to be 5 over 3. Okay, cotan theta is 1 over tan theta, so it's going to be 3 over 4. Okay, now I'm going to point out, how do I remember this? So tan and cotan make sense because they both say the word tan, but people get confused with sine, cosecant, cosine, and secant. So what I always remember is that they both have S and C. Okay, but if you notice, they swap. Okay, so that's how I remember. It's always the opposite letter. So if you have a cosecant, it starts with a C, so that's going to be 1 over sine, the opposite letter. If you have a secant, it's 1 over cosine, the opposite letter. Okay, so that's how I remember. These two I just make sense because they both say tan in them. The other thing I was going to write on here, that you probably have heard before, is SOHCAHTOA. So this is a way to remember these definitions. So I've seen this a few ways. The one I actually like looks like this. Okay. So what this tells you is that the sine function is the opposite over the hypotenuse. The cosine function is the adjacent over the hypotenuse. And the tan function is the opposite over the adjacent. Okay, you might also see it written out. Okay, it does the same thing. You just want to group them into threes, and then it tells you what those three are doing. And then the other three are just 1 over the appropriate one. So then you just flip the appropriate one. So that's just for the sine, the cosine, and the tangent. But that's a good way to remember, and I'm sure you've heard it before because it's very, very common. But if you have trouble remembering, then that definitely can help. Okay, let's do one more example, and then I'm going to leave one for you. So if I know that sine theta is root 5 over 5, and I know cosine theta is 2 root 5 over 5, then what are the other values? So you don't even have to make a triangle here, but you could. So I'm going to just do them without making a triangle. So tan theta has to be sine theta over cos theta, which means that it's going to be root 5 over 5 divided by 2 root 5 over 5. So that's root 5 over 5 multiplied by 5 over 2 root 5. And then the 5 over 5 cancels, the root 5 over root 5 cancels. So this is actually just 1/2. Which means that cotan theta is going to be the flip of that. So 1 over tan theta. So it's going to be 2 over 1. Secant theta is 1 over cos theta. So it's the flip. So it's going to be 5 over 2 root 5. Okay, and cosecant theta is 1 over sine theta. So it's going to be 5 over root 5, which is actually root 5. So this also is 1/2 root 5, if you want to simplify. But you could also make a triangle. So what you would do is you make your right triangle. Okay, so that's not very good, but so that's our right triangle. Let's put the angle theta here. Okay, so sine theta equals root 5 over 5 tells me that the opposite side should be root 5 and the hypotenuse should be 5. Okay, so that I'm just going to write, so sine theta equals root 5 over 5 tells me that. Now cosine theta equals 2 root 5 over 5 tells me that this side should be 2 root 5 and this side is also 5, which makes sense. Okay, they're equal, so this probably is the right thing. But you could have also found this by checking. So this side would be the square root of the hypotenuse squared minus the other side squared. So that's the square root of 25 minus 5. So root 20, which is root of 4 times root of 5. So it is 2 root 5. Okay, so that checks out. So then you could find the other trig functions from here. So tan theta is the opposite over the adjacent. So it's root 5 over 2 root 5, which simplifies to 1/2. Okay, cotan theta is the adjacent over the opposite. So that's 2 root 5 over root 5, which simplifies to 2. Secant is the opposite, or the hypotenuse over the adjacent. So it's 5 over 2 root 5, which is exactly what we have there. And cosecant is the hypotenuse over the opposite. So again, 5 over root 5. So you could do it with a triangle, or you can do it just by knowing how the other trig functions relate to sine and cosine. Okay, so I'm going to leave number 3 for you to try. And here we're going to talk about probably the most important identity for the trig functions. So again, we do a right triangle. Okay, so let's call this A, B, and C. And then we'll put theta in here. Okay, so Pythagorean theorem tells us that a squared plus b squared should equal c squared. Okay, now if I just divide everything by c squared, what that gives me is a squared over c squared plus b squared over c squared is equal to 1. And that's actually a over c squared plus b over c squared equal to 1. And a over c is the opposite, over the hypotenuse. So that's actually the cosine value. So that's cosine of theta squared. And b over c is the opposite. Oh, I wrote opposite last time. Sorry, this is the adjacent. The opposite side over the hypotenuse. So that's actually sine of the angle, which is all squared. So that's equal to 1. So maybe I'll just write that. So sine of theta is b over c, and cos of theta is a over c. So that's how we get from there to there. Okay, so this is what we call the Pythagorean identity. So normally we write it sine squared theta plus cos squared theta is equal to 1. Okay, that is a very important identity. And I just want to make a note here. So when we write the square on the n and the s instead of on the theta, so sine squared theta like that, we actually mean sine of theta all squared. Okay, so if we wrote sine of theta squared like that, then we would mean sine of theta squared. Okay, so just be aware of that. If it's before the theta, it actually means the whole thing squared. Just because we're lazy, that's what we do. So this is the main identity, but then we get 2 for free. Okay, so if I take this identity and I divide by cosine squared theta, then I'm going to have, so tan squared theta, or sorry, sine squared theta, maybe I'll just write it. So sine squared theta over cos squared theta, oops, not equals, plus cos squared over cos squared is 1 over cos squared. Okay, so what that is, this is tan squared theta plus 1 is equal to secant squared theta. So that is another identity. Let's do a different color. So I could also instead take this and divide by sine squared theta, okay, which is going to give me sine squared theta over sine squared theta plus cos squared theta over sine squared theta equals 1 over sine squared theta, which gives me the identity 1 plus cotan squared theta is equal to cosecant squared theta. And that is yet another identity that is also true. This is for all theta. Oops, I'm in the wrong thing here. Okay, these are true for all values of theta. Okay, so it doesn't matter what theta is, as long as it's the same theta. Okay, so the theta here matches the theta here, then this identity is true. So you can use this to find some exact values. Okay, so if I have, so here, so we have secant squared of 25 degrees minus tan squared of 25 degrees. So this, so I'm just going to write down here. So this is the blue one. So let's switch to blue. So we know tan squared theta plus 1 is equal to secant squared theta. So if I take the tan squared theta over, it's going to cancel on this side. That's going to give me 1 is equal to secant squared theta minus tan squared theta. Okay, that is exactly what I have here. Secant squared of a theta minus tan squared of a theta. So because of this identity, this is actually equal to 1. And it would be true for all, it doesn't matter that it's 25 degrees. Okay, so for as long as they're the same, that would always be equal to 1. Okay, so that's using one of these. So you can obviously rearrange them as desired. Now we have some idea of cofunctions. So we define the trig functions for a particular angle. So there's 2 non-90 degree angles in that right triangle. So we call those complementary angles. Okay, so here alpha and beta are complementary angles since they must add to 90. Why must they add to 90? Well, that's because the sum of the angles in any triangle equals 180 degrees. Okay, so because I already have a 90 used up, because this is a right triangle, the other two have to add to 90. Okay, so that's why that's true. So I'm just going to, so let's say alpha is in red. So alpha has B as the adjacent side and A as the opposite side. Okay, but beta has B as the opposite side and A as the adjacent side. So if we were looking at, let's say, sine of alpha, then it's the opposite for alpha over the hypotenuse. The hypotenuse is always c. So it's going to be a over c. Okay. But if I look at, say, cosine of beta, so now I'm using the beta angle, I want the adjacent, which is also a, over the hypotenuse. So notice that those are equal since the opposite for alpha is equal to the adjacent for beta. So we get these things are equal. So similarly, cosine of alpha is going to be the adjacent over the hypotenuse, so b over c. And that's going to be the same as sine for beta, because the opposite for beta is equal to the adjacent for alpha. Okay, so they switch. So this gives us the complementary angle theorem. So what that means is that cofunctions of complementary angles are equal. Okay, so that means so sine of alpha is equal to cos of beta, as we just saw in the example. But it also means tan of alpha is equal to cotan of beta. So here we have sine alpha over cos alpha equals cos beta over sine beta, but so they're equal on the top and the bottom, so this is going to be true as well. And cosecant of alpha is going to be equal to secant of beta, again because the sine and the cosine values are equal. Okay, so you get all three of those equalities. So let's do, I'm going to do one example here and leave the other one for you to do. So let's do the first one. Okay, so now I noticed here that 12 degrees plus 78 degrees is actually 90 degrees. Okay, so that means that these are complementary angles. Okay, which tells me by the theorem above that tan of one of them is equal to cotan of the other one. Okay, so those two things are actually equal, which means that they subtract to give me 0. Okay, so this is going to simplify to 0. Okay, now I'm going to leave part B for you to do. And those are the basics for the trig functions defined on a right triangle.